A power plant technician was paid $10,000 to turn one screw, not to rebuild the engine or install new equipment, just to identify and turn the right screw. That single action restored power to an entire facility worth millions.
You gotta work, never tell, keep your head down, find what you love and excel, yeah. Push and pull and repel any hate, go create what you want, feel compelled, yeah.
This same principle applies to technology today. While others are rewriting entire code bases and over-engineering solutions, smart tech professionals are finding the one screw that fixes everything. I'm about to reveal how to spot these high-impact intervention points in any tech system.
About others way before myself, yeah. I guess that's why I feel like I go through hell, damn. Wasting time on your dreams instead of mine, yeah. About to turn this franchise around on a dime, man. It's all about finding your right state of mind. It's all about turning the worst into fine. It's all about time and the work and the climb. From the thirst we will rise, I'm immersed in this life. Don't let somebody take your time and your worth. Just focus on yourself first. Don't let somebody take your time and your worth. Just focus on yourself first. Don't let somebody take your time and your worth. Just focus on yourself first. Don't let somebody take your time and your worth. Just focus on yourself first.
Most tech professionals spend their days fighting the same losing battle, working harder but seeing diminishing returns on their effort. They arrive at the office early, stay late, and fill their weekends with coding sessions and system troubleshooting. They add new frameworks to their projects, sign up for additional monitoring tools, and attend more meetings hoping to find the solution that finally breaks through their productivity ceiling. This approach creates a vicious cycle. Each new tool requires time to learn, configure, and integrate with existing systems. Every additional framework adds complexity that needs maintenance and updates. More meetings mean less time for actual development work. The harder these professionals work, the more complicated their environment becomes, and the more time they spend managing complexity instead of creating value. Research shows that 80% of tech professionals waste time on activities that contribute less than 20% to their actual results. They spend hours debugging code that could be fixed with a single environment variable change. They write elaborate unit tests for functions that will be deprecated next month. They attend status meetings where no decisions get made and optimize databases that aren't the real performance bottleneck. Picture the overwhelmed developer who spent 3 weeks rewriting an entire authentication system because Logan was taking too long. They refactored the code, implemented caching layers, and optimized database queries. The real problem was a misconfigured load balancer that was routing requests to a server in the wrong geographic region. A 5-minute configuration change would have solved the issue completely. This trap keeps people busy, but not productive, creating the illusion of progress while burning through energy and time. Busy work feels productive because you're typing code, attending meetings, and completing tasks. Your calendar looks full, your commit history shows activity, and your manager sees you working hard. Meanwhile, the core problems persist because you're treating symptoms instead of causes. The fundamental issue is that most tech problems have a single point of failure that, when addressed, eliminates dozens of downstream issues. Complex systems create cascading effects where one poorly configured component impacts everything else. A slow database query affects API response times, which triggers timeout errors in the front end, which causes user frustration and support tickets. Fix the query, and all the downstream problems disappear. Traditional work-harder approaches in tech often make problems worse by adding layers of complexity. When faced with a performance issue, developers add caching layers, implement load balancing, and optimize algorithms. Each solution creates new potential failure points and requires ongoing maintenance. The original problem might have been solved with a simple index on a database table or adjusting a connection pool size. This mirrors the power plant story perfectly. While others would have rebuilt the entire system, replaced major components, and spent months on the project, the expert found the one critical point. He understood that complex systems usually fail at simple connection points. One loose connection creates electrical resistance, which generates heat, which causes more resistance, which eventually fails the entire circuit. The same principle applies to software systems. A misconfigured environment variable can cause memory leaks that crash servers. An incorrect timeout setting can make APIs appear broken when they're actually working fine but need more time. A wrong file permission can prevent automated deployments from working, forcing manual interventions that waste hours every week. Most developers never step back to identify these critical points. They see symptoms and immediately start treating them individually. The login is slow, so they optimize the authentication code. The database is hitting connection limits, so they increase the pool size. The API returns errors under load, so they implement retry logic. Each fix addresses one symptom while the root cause continues creating new problems. The work-harder mentality makes this worse, because it encourages firefighting instead of system analysis. When everything feels urgent, you don't have time to understand why problems are happening. You just need to make them stop as quickly as possible. This reactive approach ensures you'll keep encountering the same categories of issues because you never addressed what's actually causing them. System complexity grows exponentially when you layer solutions on top of problems instead of solving the underlying issues. Each band-aid solution becomes a permanent part of your architecture. The retry logic becomes critical for handling the timeout errors. The increased connection pools become necessary to prevent the database bottleneck. The caching layer becomes essential for masking the slow queries. Your system becomes dependent on workarounds instead of working correctly. The cognitive load of maintaining these complex systems burns through mental energy that could be applied to high-value work. Instead of architecting new features, you're debugging integration issues between your various solutions. Instead of optimizing user experiences, you're monitoring metrics for all your different workarounds. Instead of building competitive advantages, you're keeping existing systems running. Breaking out of this trap requires a fundamental shift in how you approach technical challenges. Instead of asking how to work around a problem, ask what's causing the problem to exist. Instead of adding tools to manage complexity, identify which existing tools are creating unnecessary complexity. Instead of optimizing individual components, understand how the components interact with each other. The first step to 100x ROI is recognizing which activities actually move the needle versus which ones just keep you busy. Moving the needle means solving categories of problems, not individual instances. It means removing constraints that limit everything else, not optimizing things that don't matter. It means creating leverage where your effort gets multiplied across multiple outcomes. This recognition becomes the foundation for everything that follows in our framework. Once you can distinguish between high-leverage interventions and busy work, you can start making strategic decisions about where to invest your time and energy. You can stop fighting individual fires and start removing the conditions that cause fires in the first place. Every additional tool, process, or system you add to your tech stack carries a hidden tax that most people never calculate. This tax doesn't appear on your monthly software bill or in your project budgets. It's the accumulated cost of cognitive overhead, maintenance burden, and integration complexity that quietly drains productivity from your daily work. Tech professionals accumulate tools and processes thinking each one will make them more efficient. They sign up for new project management platforms when the current one lacks a specific feature. They add monitoring services to track different metrics. They install browser extensions to automate repetitive tasks. They subscribe to development tools that promise to streamline their workflow. Each addition seems logical in isolation, but the cumulative effect creates an unwieldy ecosystem. The hidden reality is that each new addition creates maintenance overhead, learning curves and integration challenges that often outweigh the benefits. That new monitoring service requires time to configure dashboards, set up alerts, and learn its specific query language. The project management tool needs data migration from the old system, user training, and custom workflow setup. The automation browser extension breaks when websites update their layouts and requires troubleshooting every few months. Consider what happens when you need to update your password manager information across 15 different services versus 5. The time difference isn't just threefold. It's exponentially higher because you need to remember which services you actually use, figure out their different authentication methods, and navigate their various security settings. Some require two-factor authentication reset, others need account verification emails, and a few demand phone call confirmation. The real cost of context switching between multiple tools and platforms throughout a single workday compounds this problem. Your brain needs time to adjust between different interfaces, remember different keyboard shortcuts, and recall different workflows. Switching from Slack to email to project management software to code editor to terminal to browser tabs creates micro-interruptions that fragment your attention. Each context switch requires mental energy to reorient yourself and remember what you were doing in that environment. These transitions aren't just about loading different applications. Each tool has its own information architecture, visual design patterns, and interaction methods. Your muscle memory for keyboard shortcuts gets confused when different applications use the same key combinations for different functions. Your spatial memory needs to track where information lives across multiple systems. Your working memory holds context for several different tasks simultaneously. Tool proliferation creates decision fatigue through the mental energy spent choosing between options instead of executing solutions. When you need to schedule a meeting, you have to decide between calendar applications, scheduling tools, and meeting platforms. When you need to share a file, you choose between email attachments, cloud storage services, and collaboration platforms. When you need to take notes, you select from note-taking apps, document editors, and project management systems. Each decision point delays actual work completion. The decision fatigue extends beyond choosing which tool to use. Within each tool, you face configuration decisions about notifications, integrations, and workflow settings. You spend time evaluating whether to upgrade to premium features, whether to integrate with other services, and whether to migrate existing data. These meta decisions about tool management become a significant portion of your cognitive workload. Teams that recognized this pattern and reduced their tool count by 70% saw productivity increases of 200% or more. One development team eliminated 12 different communication channels and consolidated everything into 2 primary platforms. They removed 5 different file sharing services and standardized on a single cloud storage solution. They discontinued 7 different project tracking systems and chose one comprehensive platform. The time previously spent managing tool complexity got redirected toward actual development work. Another team discovered they were paying for 19 different software subscriptions, but only actively used 6 of them. The unused tools weren't just wasting money, they were creating phantom complexity. Team members would occasionally use the dormant tools, which meant maintaining login credentials, remembering different interfaces, and dealing with data synchronization issues between systems. The psychological burden of managing multiple systems fragments focus and attention in ways that persist beyond active tool usage. Even when you're not actively using a tool, knowing it exists in your environment creates background cognitive load. You need to remember what information lives where, which tool is best for different tasks, and how various systems connect to each other. This distributed cognition prevents deep focus on any single task. Your attention gets scattered across multiple notification channels, status indicators, and update streams. Each tool wants to inform you about its specific domain: project updates, system alerts, social mentions, calendar reminders, and task deadlines. Managing these information flows becomes a full-time job that interferes with focused work. You're not just using tools to accomplish tasks, you're constantly managing the tools themselves. The Pareto principle applies directly to tool usage. A small number of tools likely handle the majority of your actual work needs. Most professionals discover that 3 to 5 core applications account for 80% of their productive output. The remaining tools handle edge cases, one-off tasks, and specialized functions that occur infrequently. This realization reveals how much overhead comes from maintaining rarely used systems. The core tools typically include a code editor, communication platform, version control system, and documentation tool. Everything else serves supporting functions that may not justify their complexity cost. Secondary tools often duplicate functionality that exists in your core applications. Many code editors include terminal access, file management, and basic project planning features that eliminate the need for separate applications. Identifying your core tools requires honest assessment of daily workflow patterns rather than hypothetical use cases. Track which applications you actually open and interact with over a typical week. Measure time spent in each environment and the value produced through that time investment. This analysis reveals the difference between tools you think you need and tools you actually use effectively. Subtraction often unlocks bigger productivity gains than addition because removing complexity creates exponential benefits. Each eliminated tool reduces maintenance overhead, learning burden, and integration points. Fewer systems mean fewer failure modes, security vulnerabilities, and compatibility issues. Simplified environments enable deeper mastery of the remaining tools and more focused attention on high-value work. The most powerful tech switch might be turning off or removing systems rather than adding new ones. This counterintuitive approach requires discipline because technology companies constantly promote solutions for problems you might not actually have. Marketing messages emphasize what you'll gain from adopting new tools, not what you'll lose to increased complexity. There's a systematic way to identify which tech interventions will create exponential returns versus linear improvements. Most technology decisions get made through gut feeling, peer recommendations, or feature comparisons that miss the fundamental question of leverage. A developer sees a new framework trending on social media and decides to rebuild their application. A team adopts a popular project management tool because their competitors use it. A company invests in machine learning capabilities because industry reports suggest it's important. These decisions ignore whether the intervention will actually multiply existing efforts or just create more work. The Advanced Tech Multiplier framework provides a decision-making structure specifically designed for technology choices that can compound your results. This framework evaluates potential interventions across 3 critical dimensions that determine whether your time investment will pay exponential dividends or disappear into busy work. Unlike traditional cost-benefit analysis that focuses on immediate returns, this framework identifies changes that amplify everything else you do afterward. Most people make tech decisions based on features or popularity rather than actual leverage and impact potential. They read comparison charts highlighting different capabilities, watch demo videos showing polished interfaces, and ask colleagues about their tool preferences. This approach optimizes for the wrong variables because impressive features don't guarantee multiplicative results. A tool with fewer capabilities might create more leverage if it integrates seamlessly with your existing workflow and eliminates friction points that slow down every other process. The three core components of the framework are impact radius, effort investment, and sustainability factor. Impact radius measures how many downstream processes are affected by the intervention. A database optimization that speeds up every query has a larger impact radius than a user interface improvement that affects one specific page. Effort investment calculates the time and resources required not just for initial implementation, but for ongoing maintenance, learning curves, and integration work. Sustainability factor evaluates how long the benefits will last given changing business requirements, technology evolution, and team dynamics.
Gotta focus on yourself, on your faith, on your dreams, on your mind, on your health, yeah. You gotta work, never tell, keep your head down, find what you love and excel, yeah. Push and pull and repel any hate, go create what you want, feel compelled, yeah. And once you finally get a taste of the race, you'll never look back once you felt that. Don't let somebody take your time and your worth, just focus on yourself first. Don't let somebody take your time and your worth, just focus on yourself first.
Impact radius requires mapping the connections between different parts of your system to understand cascading effects. When you automate deployment processes, every feature release afterward benefits from reduced manual effort, fewer human errors, and faster feedback cycles. When you implement single sign-on authentication, every new application integration becomes simpler, user onboarding gets streamlined, and security management improves across all systems. When you standardize data formats between services, every new integration requires less transformation logic and debugging time. Effort investment includes hidden costs that don't appear in initial planning. Learning new technologies requires time for research, experimentation, and skill development before productive work begins. Integration efforts often uncover compatibility issues, data migration challenges, and workflow changes that weren't obvious during evaluation. Maintenance overhead accumulates through software updates, security patches, configuration changes, and troubleshooting sessions that continue long after initial deployment. Sustainability factor predicts whether benefits will compound over time or diminish through changing circumstances. Some interventions become more valuable as your system grows. Automation scripts that handle increasing volumes of work, monitoring systems that provide more insights as complexity increases, and standardized processes that onboard new team members faster. Other interventions lose value as requirements evolve. Custom integrations that become obsolete when vendors change APIs, optimization techniques that become irrelevant with hardware improvements, and specialized tools that don't adapt to new business models. You can score potential tech interventions using these three dimensions to create a multiplier effect calculation. Rate each dimension on a scale where higher numbers indicate greater leverage potential. Impact radius gets scored from 1 to 5 based on how many processes, people, or systems benefit from the change. Effort investment gets reverse scored from 5 to 1 where lower effort requirements receive higher scores. Sustainability factor gets rated from 1 to 5 based on how long benefits will persist and grow. Multiply the three scores together to generate a leverage index that helps prioritize competing opportunities.
gotta focus on yourself, on your faith, on your dreams, on your mind, on your health, yeah. You gotta work, never tell, keep your head down, find what you love and excel, yeah. Push and pull and repel any hate, go create what you want, feel compelled, yeah. And once you finally get a taste of the race, you'll never look back once you felt that. Don't let somebody take your time and your worth, just focus on yourself first. Don't let somebody take your time and your worth, just focus on yourself first. Don't let somebody take your time and your worth, just focus on yourself first. Don't let somebody take your time and your worth, just focus on yourself first.
The difference between solutions that scale linearly versus exponentially becomes clear through this scoring system. Linear solutions solve one problem at a time. Each unit of effort produces 1 unit of result. You build a new feature, and that feature provides value. You fix a bug, and that bug stops causing issues. You write documentation, and people can reference that specific information. The benefits don't compound or create additional value beyond their immediate scope. Exponential solutions solve categories of problems. Each unit of effort produces multiple units of result that continue generating value. You create a testing framework, and every future code change becomes safer to deploy. You implement continuous integration, and every team member gets faster feedback on their work. You establish coding standards, and every new developer produces more consistent and maintainable code. These solutions create conditions where subsequent work becomes more effective. Force multipliers in technology are changes that amplify everything else you do rather than just solving one isolated problem. They remove friction from your regular workflow, eliminate entire categories of manual tasks, or create infrastructure that makes future improvements easier to implement. A well-designed API doesn't just enable one integration, it makes every future integration faster and more reliable. A comprehensive logging system doesn't just help debug one issue, it accelerates troubleshooting for every problem that occurs afterward. Consider the difference between optimizing one specific database query versus implementing comprehensive database indexing strategies. The first intervention solves one performance problem. The second intervention improves query performance across your entire application, makes future queries faster by default, and provides infrastructure that benefits every new feature development. The effort investment might be similar, but the impact radius and sustainability factor are dramatically different. One question can instantly reveal whether a tech task deserves your time or should be eliminated from your workflow entirely. This question cuts through the noise of competing priorities, urgent requests, and interesting technical challenges to identify what actually matters. It separates high-leverage work from busy work in seconds, preventing you from spending hours or days on activities that produce minimal results.
Once you finally get a taste of the race, you'll never look back once you felt that. Don't let somebody take your time and your worth, just focus on yourself first.
The adapted version of Jim Quick's strategic question specifically for technology decisions asks, What screw or switch will give me the highest return on my tech effort? This question forces you to think beyond immediate fixes and consider which intervention will create the most widespread impact. Instead of asking how to solve the problem in front of you, you ask which problem to solve that eliminates the most downstream issues. Most tech professionals never ask this question and instead default to working on whatever seems most urgent or familiar. They open their task management system and start with the item marked highest priority. They respond to the latest bug report or feature request without considering whether it addresses root causes or just symptoms. They work on problems within their expertise area, even when higher leverage opportunities exist outside their comfort zone. This reactive approach keeps them busy but limits their impact to incremental improvements.
It's all about finding your right state of mind. It's all about turning the worst into fine. It's all about time and the work and the climb. From the thirst we will rise. I'm immersed in this life. Don't let somebody take your time.
The urgency bias makes surface-level problems feel more important than systematic issues. A user interface bug that affects customer experience seems critical because you can see immediate user impact. A slow database query that affects multiple systems seems less urgent because the impact is distributed and harder to measure. The visible problems get attention while invisible bottlenecks continue limiting overall system performance.
Gotta focus on yourself, on your faith, on your dreams, on your mind, on your health, yeah. You gotta work, never tell, keep your head down.
Breaking down how to apply this question to debugging reveals the difference between symptom treatment and root cause resolution. When API calls start timing out, the obvious response is increasing timeout values or implementing retry logic. The high-leverage question asks what underlying condition causes timeouts to occur. The answer might be a database connection pool that's too small, a memory leak that accumulates over time, or a network configuration that routes traffic inefficiently. Fixing the root cause eliminates timeouts completely rather than just making them easier to handle. Feature development scenarios benefit from asking which capability unlocks multiple use cases rather than just solving one specific requirement. Building a custom reporting interface for one department solves their immediate need. Building a flexible data export API solves the same need while enabling future reporting requirements, third-party integrations, and automated data processing workflows. The effort investment might be similar, but the leverage multiplier is dramatically different. System optimization requires identifying what bottleneck limits everything else, rather than optimizing components in isolation. Front-end performance improvements make pages load faster, but if the database is already maxed out, the improvements won't scale with increased traffic. Database optimizations might not help if network bandwidth is the limiting factor. The high-leverage intervention targets the constraint that prevents everything else from performing better. The difference between surface-level fixes that feel productive and deep interventions that solve entire categories of problems becomes obvious when you apply systematic thinking. Surface-level fixes address specific instances of problems. This login form is slow. That API endpoint returns errors. This deployment process occasionally fails. You can spend weeks optimizing individual components and see measurable improvements in each area. A real example demonstrates this principle clearly. A developer spent 3 weeks optimizing application code because users complained about slow response times. He profiled function calls, implemented caching layers, and rewrote algorithms to be more efficient. The application code became faster, but user experience barely improved. The real bottleneck was a database configuration where the connection timeout was set too low. Under load, connections would drop before queries completed, forcing applications to retry operations. Adjusting this single setting took 10 minutes and solved the performance issues completely. Every item on your tech to-do list falls into one of 4 categories, and knowing which one determines whether you should touch it at all. This categorization system prevents you from treating all tasks as equally important and helps you allocate your most valuable resource, your focused attention, to activities that create exponential returns. Without this framework, you end up applying expert-level skills to mundane problems, while high-leverage opportunities sit unaddressed. The 4Ds framework adapted for technology work provides clear decision criteria: do, delete, defer, and delegate. This system forces you to make conscious choices about every task rather than defaulting to your inbox or whatever feels most urgent. Each category has specific characteristics that help you quickly identify where any given task belongs and what action to take. Most tech professionals try to do everything themselves, leading to burnout and suboptimal results across all tasks. They review every piece of code personally instead of establishing quality standards others can apply.
About others way before myself, yeah. I guess that's why I feel like I go through hell, damn. Wasting time on your dreams instead of mine, yeah. About to turn this franchise around on a dime, man. It's all about finding your right state of mind. It's all about turning the worst into fine. It's all about time and the work and the climb. From the thirst we will rise, I'm immersed in this life. Don't let somebody take your time and your worth. Just focus on yourself first. Don't let somebody take your time and your worth. Just focus on yourself first. Don't let somebody take